In this video, we review topics such as constant, simple assignments, compound assignments, increment, decrement, exchanges, and input and outputs. So constant is that you can give a name to a value. The reason why we use constants is that, for example, in your program, you are dealing with a class size. Suppose class size is 25. So in some part of the program, you use 25 to represent the size of the class, and some other part you use 25 again, and then a while later you might use a class size 25 again to calculate the average of the class and so on. What if the class size changes and now it's 26? Then you need to locate all of those places where 25 is used, and then you need to change it to 26 and the like. So you will find that such is not very convenient. So constant is a feature that you can give a name to a value, and then after that you can use just the name. So the how to define a constant is very similar to define a variable. Suppose the class size is 26 at this moment, then to declare a variable to store 26 is integer n is 26. This is how to declare a variable. But to define a constant, you just begin with the keyword constant prior to int. And then typically you give the name of the constant in an uppercase like this one, but you don't have it to. So that is just a convention, not a grammar requirement. So by giving constant at the beginning of a variable declaration, then it becomes a constant. Here the meaning of a size is not a variable but a name of the constant 26. So once constant is defined, from that moment on, whenever you need 26 as a class size, just use the name of the constant size instead of 26. Here, name of the constant again, and so on. But the convenience of using constants is that if the class size now changed to 30, then all you have to do is just change it at the declaration of the constant. Then after that, where you use the name size, 30 is used. So that's a benefit of using constants. So constants you can define for any type. Suppose I have a float number called n as a 3.14, then you can define this as a constant. Then n is not a variable but name of the variable, name of the constant, the 3.14. So you can define constant for double type, something like this. So any type you can do that. It's const char special symbol or space. You can have something like this. Then instead of star, you can use SP from that moment on. So that is a constant definition. So next topic is a simple assignment. Simple assignment meaning that when you have a variable declared, you can assign value to that. If you have another variable, then you can assign some value to that. You can assign into a variable out of the value, existing value. Then currently k is 21, so 21 is assigned into k. So that's a simple assignment. When you do the assignment, you can also have expression on the right hand side of the assignment. So n, you can do k plus 20 plus n, something like that. So you can give expression on the right hand side of the assignment. Then the expression is evaluated. The result is stored into the variable on the left hand side of the assignment. So that's a assignment. The compound assignment is a special syntax for shortcut notation. So general syntax is that you have a variable and then you have an operator like a plus, minus, multiplication, and then equal sign, and then you have an expression. That's a general syntax. So simple example, suppose I have a variable n defined, and initialized as a 5. Then I can do variable n, the operator, equal sign, and any expression. So that's called the compound assignment. Then the meaning of this one is a variable n and then equal sign, and the variable n is repeated, and then the operator before the assignment, which is plus, and then whatever is on the right hand side of the assignment is repeated. So this is a unfold form, and this is a compound assignment folded form. So whenever you see compound assignment, just unfold this way and then guess what the operation means. So here general syntax is a variable, any operator, equal sign, expression. So it unfold the form of that syntax is, if we unfold that variable, equal sign, variable is repeated, operator is there, and then expression comes after that. So let's try some complex one. Suppose I have a double type of variable d. Let's assign to point 1, and then if I say d times equal n plus 2. So what does that mean is, so see the general syntax, a variable, the operator equal expression. So variable here is a d, operator here is a star, which is multiplication, and then we have equal sign, and the right hand side n plus 2 is expression. So to unfold this one, we begin with a variable. So put variable, which is d, and then equal sign, variable d is repeated, and then operator here is a star, and then expression, which is the right hand side of the equal sign. And this expression, if it's some operator is there like a plus, it should be treated as a one thing, so we need to put into parentheses. So if you don't put into parentheses, then because of precedence, this multiplication comes first. But this is a expression, and then the variable is on the same level. So any expression which is more than one variable, you need to put into parentheses. So that's the one. So unfold is relatively easy by remembering those syntax to unfold that, but you should be able to go backwards as well. So given this unfolded expression, you should be able to make a folded shortcut notation. For example, if I have n is n times 2, then compound expression should be variable n, and then equal n is repeated, so operator comes first, and then equal sign, and then expression is the one after the operator, so this 2. So that's how to fold, converting into compound assignments. Next topic is increment and the decrement. The C++ has a special symbol. Suppose I have variable n with a 1. A special symbol is plus plus n, which is increment the value of n. So effectively, that's n is n plus 1. If I use a compound assignment, that is n plus equal 1. That's the one. So when you do increment, you can put plus plus sign after the variable. So if you use it like this standalone, plus plus n or n plus plus, effect is the same. So n is incremented, and now n is incremented again. Similarly, you have a decrement minus minus n or n minus minus. So simply to decrement the value, so which is similar to same as minus equal 1 in compound assignment. So plus plus or minus minus is called increment or decrement. But when you put the plus plus before the variable, then that is called a pre-increment. So here we have another terminology called pre-increment or pre-decrement, which means that the symbol plus plus or minus 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 is used prior to the variable, like here or here. That's called the pre-operation. But if you put plus plus or minus minus after the variable, that is called the post-increment or post-decrement. If you use increment or decrement, pre or post, if you use a standalone statement like this, there is no difference, exactly the same effect we have. But if you use those increment or decrement as a part of expression, then we have some different result. So here, pre case, suppose we have a variable k, which is assigned into 1. Then suppose I have another variable m defined there. So if I assign k into m, m should be 1. If I do plus plus, it's a pre-increment. M is a pre-increment, then we expect that the k is incremented, which is 2. Now 2 is assigned into m, so we should get that result. So let's compile the program and then see how it works. So m is 2, that's what we expected. But if we do post increment and then see what is the value of m and k, this way is a post increment is used. So let's compile the program and then let's run it. Then what it says is that m is 1 but k is 2. So here something happened there. So post increment, the meaning of a post increment is here k is used for assigning into m. So post increment means use value of k first and then increment. That's a post. Pre-increment means increment first and then use the value in k. So in post increment, k is used for assignment and then k is incremented. So currently k is 1. So k is used for assignment into m. So 1 is assigned into m and then k is incremented. Now k becomes 2. So within this we have 2 steps of operations. That's why m gets 1 but k is anyway incremented by 2. So let's change it to pre-increment. If I do pre-increment, the pre-increment means increment k first. So k is now 2, and then assign the value into m. m also gets 2. So here, if I compile it again, and then see that, run it, m is 2 and k is 2. So that's a pre-increment and post-increment issue. If you do a very similar thing for post, same thing happens. But in decrement, exactly the same thing happens. So if I do pre-decrement, so k is decremented first, and then it's assigned. So k is currently 1, decremented first, k is 0, and 0 is assigned into m. So what we expect is 0 and 0. But if I use a post decrement means use the value of k first for assignment, so which is 1. 1 is assigned into m, and then k is decremented. Now k becomes 0. So we can verify that. Yeah. So m is 1 and k is 0. So that's a pre or post decrement. So if you use increment and decrement like a standalone, not part of any other expression, then it's simply increments or decrements. But if you use increment and decrement as part of expression, like here as assignment, then pre means do the increment first and then use it. Post means use the value first and then increment. So that's a pre or post increment differences you need to understand. Next topic is exchange. So here what exchange means is that as follows. Suppose I have integer variable n, which is 5, and then I have another variable k, which is 2. So we want to swap those values. So the value in n is assigned from k, and k gets a value from n. So what we can do naively is that n gets from k and k gets from n. But if you do so, this will not work. So here n is n, k is k. Then if I compile the program, and then if I run it, n and k are the same. So we didn't get the swap done. So why is this happen is as follows. So here we have defined n and assigned 5. So variable n has a value 5. So we have another variable k, value 2 is assigned. So here those two statements does like that. Now in this statement k is assigned into n, so value of k is copied into n, so n gets 2. Then the last one, n is copied into k, n is copied into k, so 2 is there. So the result is n and k are the same. So you cannot swap the variables like this. So we need to do something else. The reason why it didn't work is that if you do assignment like this, the value in n is lost. So what you need to do is we need to introduce a temporary variable. So in temporary variable, let's save a value of n. So before n gets lost, save it into temporary variable. So now k is copied into n, but into k, since n is lost, but we saved it into temp variable. So from the temp, we copy the original value of n into k. So we need to introduce a third variable to exchange two variables. Then clear is to clear the screen, compile the program, and run it. So we have n and k swapped. It's exchange. Last topic in this video is input and output. So we all have used the cout. If I have a variable n is 20, then we do cout with the double quotes. We can give us some text message. The value of n is, and then variable n, then give a line break and so on. So that's how we do output in the program. You can cascade those angle brackets to do many things for cout at the same line. And then we can read, suppose I have a variable k defined, then using cin, I can read a value from the keyboard. So at this moment, the program halts. And then if I do cout, K is K in the L. So if I run this program, so value of n is 20, but at this moment, program is simply waits for input. So here, if I type 50, this case 50 there. So at this moment, if you simply run the program, nothing happens. So the best way to do so is a prompt message for the user. Enter an integer. Something like this. Without a line break, but giving blank, then those who runs the program, it's very clear why program is being halted there. Then if you type the number and then something happens. So typically when you read from the keyboard, before you do so, give some prompting message is always a nice way to give them the status of a program running to the user.